This experiment involves carbohydrates. We're going to look at different types of carbohydrates, their reactions and parts of their structures, and so forth. So what is a carbohydrate? It is a polyhydroxyaldehyde or ketone. Let's break that down. Polyhydroxy means it has many OH groups attached to the carbons. Remember that an OH group, this is a hydroxyl group. Okay, they also have a carbonyl group. The C double bond O is carbonyl. And so if the carbonyl group is on an end carbon, like the end of a chain, then it's an aldehyde. A ketone has it somewhere that's not an end. It doesn't have to be right in the middle, just not on an end. Okay, we're going to look at sugars and see if they're reducing sugars or not. It tells you something about the structure of the sugar, if it can act as a reducing agent to Benedict's reagent. In other words, a reducing sugar will reduce Benedict's reagent, or you could say that Benedict's reagent oxidizes the sugar. Like any redox reaction, it can be stated either way. So let's look at what happens in this. We have a reducing sugar. We will look at why some sugars are reducing and why some are not. And then when you add Benedict's reagent, and I use this color because this is the color of Benedict's reagent, it's kind of an aqua. And if they react, if the reducing sugar can reduce Benedict's, then you get a color change. You get orange, green, could be brown, really any color, but these tend to be the colors. And the exact color you get may depend on like how long you let it sit and react. But anyway, if you do Benedict's and the Benedict's assay and you get a color change, we would say that the sugar is a reducing sugar. Not all sugars do this. All monosaccharides do. Most disaccharides do, but we'll look at an exception, sucrose. And then no polysaccharides are reducing. We're also going to look at the reaction of hydrolysis. In hydrolysis, you're usually looking at really large carbohydrates like a starch or a big polysaccharide, and breaking it down into smaller sugars, smaller units. But it's hydrolysis even if you have a disaccharide broken down into just the two monosaccharides. But anyway, so hydrolysis means breaking down larger carbs. Oh, and I want to point out, we've seen hydrolysis before when we made aspirin. The reverse reaction where the aspirin was split back into the reactants, that was a hydrolysis reaction as well.